Namaste, welcome you all. Today we will discuss about the concept of resistivity and conductivity of a substance. In previous class we learned about the concept of resistance, right? Resistance means the opposition to the flow of the electrical current. And today the concept is resistivity, or it is also called as a specific resistance. To understand that thing, I will tell you a very simple example. Imagine there is one square box, and that square box is having length as 1 meter, breadth as 1 meter, and height as 1 meter. Inside the square box, if you put any one small particle and just move it, then the particle will move randomly, or in a complete zigzag manner it will move. The same concept I will explain you here also. The resistance of a conductor of unit length and unit area of cross section. In the sense, imagine there is one conductor. This is the conductor, and this conductor is having 1 meter length, 1 meter height, and 1 meter of breadth. The same concept. Observe here, the resistance of a conductor of having unit length. Unit length means you can imagine 1 meter of length. And unit area of cross section, 1 meter length, 1 meter height, and 1 meter of breadth. Okay, this concept which is having the unit length and unit area of cross section, that complete opposition created by that substance is generally called as a resistivity. That means inside that conductor, for the flow of the electrons, certain opposition is created. No need of taking 1 meter of length, 1 meter of height, or 1 meter of breadth. Imagine you can take 1 centimeter also. 1 centimeter of length, 1 centimeter of breadth, and 1 centimeter of height also. Observe here, the resistance of a conductor of unit length and unit area of cross section. This complete internal concept, imaginary concept, is generally called as a resistivity, or it is also called as a specific resistance. And to understand this thing, I will tell you one formula here. Rho is equal to Ra divided by L. This is the Greek alphabet rho, which is equal to R into A divided by L. R is indicating resistance created by that substance. Resistance, it is a one-dimensional concept. You can take only length, but in case of resistivity, you can take length, breadth, and height. Three-dimensional concept. The resistance you have to take first, and then you have to take the area and to the length. Okay, divided by the length. This complete set is called as resistivity. Rho is equal to Ra divided by L. This is the formula of the resistivity. And SI unit for this resistivity is ohm meter. You can ask the question, how this SI unit will come? Generally, resistance is having the SI unit as ohm, and area is having the SI unit as meter square, and length for length it is meter. Meter and meter square that get cancelled, only ohm meter will remain. That ohm meter is the SI unit of the resistivity. And also remember another one fact, this resistivity does not depend on its length as well as the area of cross section. That means it does not depend upon how much thickness the wire is or how much the thin wire is. It does not depend upon the area of cross section. And also it does not depend upon the length of the conductor. The length may be 100 meter, the length may be 10 meter, whatever it may be, it never depend upon the length of the conductor as well as the area of cross section. If you understand this concept properly, then you can easily understand the concept of a conductivity or specific conductance. Very simple. The reciprocal of the resistivity is generally called as conductivity. You can observe the symbol here, it is a rho. The rho is taken here. The reciprocal of this substance is generally called as a conductivity. Okay. Also, you can also write it as sigma is equal to L divided by Ra, because L is in denominator part here, but here it will come in numerator part. And Ra is in the numerator part here. When you take the reciprocal, it will come in denominator part, right? So that's why the reciprocal of the resistivity of a substance is generally called as a conductivity, or it is also called as a specific conductance. And also remember, the SI unit of the conductivity is Siemens per meter. It is 1 SI unit, or you can also write it as per ohm per meter also, because ohm meter is the SI unit of the resistivity. When you take it at this position, when it comes in the numerator part, the ohm meter can be written as per ohm, and meter can be written as per meter. Per ohm, per meter you can write, but generally they are going to make use of the Siemens per meter. And also remember, this conductivity, it depends upon the length of the substance, resistance of the substance, and area of cross section. Remember this difference properly. Conductivity depends on length, resistance, and area of cross section. But the resistivity of a substance, it never depends upon the area of cross section and length. So this is what the explanation of the conductivity and resistivity of a substance. In examination, they will ask you, define resistivity and write the formula of the resistivity and its SI unit, or they may also ask you, define conductivity and its formula and write its SI. Or they may also ask you the question, write the difference between the conductivity and resistivity of the substance. At that time, you can write all these things.